Hello, and welcome to SAT Math 101. This video is a part of SAT Math 101, a completely free and full SAT Math course available on my website. And when I say free, I really mean it. There are no subscriptions, no registrations, no paywalls, and no hidden fees. Everything is available to everyone at no cost. Well, while YouTube contains the lessons themselves, the website offers the complete learning experience. Topics are organized into shorter, focused videos, making it easier to study at your own pace and revisit exactly what you need. In addition to the videos, you'll find written notes, lesson summaries for a quick review, practice materials, and links to Desmos guides and other helpful resources. The website also includes an exclusive fundamental section that is not available on YouTube. It covers the core concepts and techniques assumed throughout the rest of the course and helps build a strong mathematical foundation before moving on to more advanced topics. So if you'd like the complete SAT Math 101 experience, including all of these resources, please check out the link in the description. Once again, everything is completely free, no sign up is required. Now let's get started. Before bluntly diving into the variety of some weird tricks and techniques of computing percents, let's firstly figure out what is the concept behind it. Assume that you face this sort of question: what is the 15% of 24? And it would be possible to answer this question if we knew what percent is. Let's figure out this in the first place, okay? What is the percent? Well, the title actually speaks for itself. Percent. Percent, by definition, is a 100th part of a number. It's 100th portion of a number. It's a result of division of 24 by 100. Okay, we take 24 and divide it into 100 equal parts, and each of the parts we call a percent. Okay, it's a very simple definition, right? So we calculated 1%, and we want to actually compute 15 of such percents. Well, we already know the value of one such percent, and let's just multiply it by 15 in order to calculate 15% of our number of 24. And this actually will be our final result. Let's go to Desmos and calculate it. 15 times 24 over 100, and this is 3.6. So we say that 15% of 24 is 3.6. Okay, this is very simple. You should just know the definition of percent, and it already makes possible to calculate all sorts of percentage problems. Okay, and here is the second question. What is 30% of 160? Let's firstly figure out what is 1% of 160. Okay, 1% of 160 is equal to division of the 160 by 100, and it will be equal to 1.6. And we are interested in calculating 30 such percents, right? 30 such percents. So 30% is 1.6 times 30. This will be our result. Let's calculate it. 30 times 1.6. This will be 48. Great. So, well, calculating percents is very easy if you know definition. So, in summary, we are able to successfully work with any phrase of the following form. We realize that in order to calculate x% of some number b, we recall the definition of percent. It's just 100th part, 100th portion of this number b, right? So it leads to division of b by 100, and this way we calculated one such percent, but we want to take x such percents, So we multiply this 1% by their whole entire amount, right? So x% of b is mathematically represented by expression x times b over 100, or I can rewrite this in a little bit different form. It's just x over 100 times b, okay? And in the future, we'll see expressions, phrases of the following form. A is x% of b. And you are expected to always be able to rewrite this phrase in a mathematical language, okay? Okay, you realize that this is x over 100 times b. You should also be able to interpret this is as equal sign, okay? And a is just a, okay? So this phrase, which you will see quite a lot in the future, should be always interpreted as the following equation. A is equal to x over 100 times b, okay? And being able to interpret this phrase and translating it into the corresponding equation allows you to sort quite a number of different problems related to percents. For example, you already are able to solve these sorts of questions. For example, a number is some number of percents of what? Or a number is how many percents of some another number. You can already answer these sorts of questions because you just recognize here this phrase and you translate it into the following equation, right? Here I use this equation and write 15 is equal to 67 over 100 times x, and this is an equation where I can find the value of x. And here the same story works. 112 is equal to x over 100 times 4. And this is also an equation where I can find the value of x, right? So if you are able to always recognize this sort of phrase and interpret it and translate it into the corresponding equation, then you are able to solve already quite a number of different problems related to percents. There are some mental shortcuts that we can use. For example, if you want to calculate 10% of x, of course we already know that it's x times 10 over 100. But at the same time, we may go further and say that, okay, this is a fraction, but it's also 0.10 times x, okay? So basically, if we look at the beginning and at the end of the problem, then we are asked to calculate 10%, and we calculate it by multiplying x by 10, but we also have written the 0 in front of it, right? Basically, it's just a division by 100, right? And the same story works actually here. You may understand that here will be a multiplication of x by 0.20. Here it will be a multiplication of x by 0.67. Okay, so if you want to calculate a percent, you can do it by multiplying the number of x by the corresponding number that is less by a factor of 100. Okay, and the same story works here, but here it will be x times 1.23 or x times 2.35. Okay, you should also be familiar with the concept of percent increase and percent decrease, and you need to be aware of the two common phrases. A is x% greater than b, and a is x% less than b, okay? Well, a is x% greater than b. How it works? You get b, right? You increase it once more by x%, and thus you get a, okay? You have b, you decrease it by x%, and you get a. It means that a is x% less than b, okay? Well, mathematically what it means, you have b, right? You have b, you increase b, you do addition, right, by x% of b, right? And this way you get a. This is a mathematical expression that corresponds to the phrase a is x% greater than b, right? It means that we get a when we have b, and we add to b x% of b, okay? And of course we can rewrite this as x over 100 times b, and this way we get that a is equal to 1 plus x over 100 times b, right? And the same story works actually here. A is x% less than b, so you have b, you decrease it by x%, and this way you get exactly a, which is x% less than b, right? So you have b, you subtract x% of b and get a, right? So a is equal to 1 minus x over 100 times b. Okay, you need to be aware about these two phrases and their corresponding mathematical representations. I want to bring to your attention that two phrases, a is x% greater than b and b is x% less than a, are not equivalent. You cannot use these two phrases interchangeably, okay? Because, well, you cannot treat percents like this because percents are relative, okay? So suppose you have to decrease 100 by 50%, and if you believe that these two phrases are equivalent, then you, when increase it back by 50%, you expect to get the same result, right? I think it's logical. If you believe that these two phrases are equivalent, then you also believe that decreasing 100 by 50%, then increasing it back by 50% will return you 100, right? But let's check if it's true. Decrease 100 by 50%, it will give us 50, right? And let's increase 50 by 50% of 50 actually, right? And it will give us 75, right? It's not 100. So you cannot use these two phrases interchangeably, okay? Because percents are relative. A percentage only has meaning relative to a reference value, okay? Next, I want to say that percents are pretty much related to exponential functions, to exponential change, okay? Suppose that you want to deposit 100 of something, or let's suppose dollars, at interest of 10%. It means that in 1 year you get 100 increased by 10%, right? So you multiply it by 1 plus 10 over 100. Okay, so this will be your balance in 1 year, and in 1 additional year, so in 2 years, you will have this result multiplied by the same factor. You agree with me, right? So this will be your balance in 2 years. And the same works further in the future, right? This will be your balance in 3 years. So working with percents very often leads to working with exponential functions, with exponential changes, when you constantly multiply a value by some number, right? So I can denote this whole expression as 100 initial value times 1 plus 10 over 100. This is a quantity of change to the power of t, where as t I might denote a number of years past. Okay.